we're going to be discussing prime and composite numbers. Now, I know some of you have been taught, oh, just remember what the prime numbers are and the rest are composite. Well, I want to show you why prime numbers are prime and composite numbers are composite. We're going to do this by building arrays. Now, what an array is it is a rectangle that represents a number. The horizontal portion of the rectangle are our rows. The vertical ones are the columns. For instance, the number 6. We can build an array by thinking of the multiplication facts. 2 times 3 equals 6. So we have 2 rows of 3, or we can flip it around and say 3 rows of 2. We can also have 1 row of 6 or 6 rows of 1. So we're going to look at the arrays for the numbers 1 through 9. The number 1 is simply 1 row of 1. The number 2 can be shown and built either 2 rows of 1 or 1 row of 2. When building the number 3, we have 3 rows of 1 or we have 1 row of 3. Now the number 4 has multiple ways of representing it. You can either have 1 row of 4, you can have 4 rows of 1, or you can have a 2 by 2 square. What that is 2 rows with 2 in each column. For the number 5, you can have 1 row of 5 or 5 rows of 1. The number 6 has 1 row of 6 or 6 rows of 1. It also has 2 rows of 3, or it can be 3 rows of 2. The number 7 is 1 row of 7 or 7 rows of 1. The number 8 is 1 row of 8 or 8 rows of 1. It also can be 2 rows of 4 or 4 rows of 2. For the number 9, you can have 1 row of 9 or 9 rows of 1. Or you can have a square of 3 by 3, which is 3 rows with 3 in each column. Now I want to look at the arrays that we just built. Some of these arrays have only 2 sets. For instance, the number 3 has 2 sets of arrays. The number 2 also has 2 sets. Let's look at the other ones. The number 5 has 2 sets. The number 7 also has 2 sets. Some of these have more than 2 sets. For instance, the number 4 and the number 9 have 3 sets of arrays, whereas the numbers 6 and 8 have multiple sets of arrays. This is what distinguishes a prime number from a composite number. The prime numbers only have 2 sets of arrays because they're only divisible by themselves and by 1. For instance, the number 3 is prime because it can only be arranged either 1 by 3 or 3 by 1. Whereas the number 6, 8, 9, and 4 are all composite numbers because they have more than 2 sets of arrays. Now I want you to notice the difference between, say, let's look at the number 6 and the number 4. Now they both have more than 2 sets of arrays, but how many arrays does the number 4 have? It has 3. It has an odd number. Anytime you have a number with an odd number of arrays, that has a special name. The number 4, the number 9, they all have a square within them. Those are called our square numbers. Now they are composite numbers, but they're also special because they have square numbers. 2 times 2 equals 4, therefore 4 is a square number. 3 times 3 equals 9. 9 is a square number. Now what about the number 1? It only has 1 by 1. It only has 1 array. Therefore, the number 1, it doesn't meet the definition to be either prime or composite. And in fact, the number 1 is neither prime nor composite. To conclude, prime numbers and composite numbers are very similar, yet they have some stark remaining differences. Think of arrays when you're thinking of prime and composite numbers. Remember, if it's a prime number, it has exactly 2 arrays. If it's composite, it has more than 2. And if that composite number has an odd number of arrays, it's a square number. All right.